So let's look at analyze web applications. After footprinting web infrastructure, the web application hacking methodology is analyze web applications. To hack the web application, first they may need to analyze it to determine its vulnerable areas. The following steps to analyze web applications: identify entry points of user inputs. The entry points of user inputs can be URL, HTTP header, query string parameters, post data, cookies, etc. Use the following tools to analyze the web application: Burp Suite, WebScrap, WASP, Zap, HTTP print. So the next is identify server side technologies. After identifying the entry points for the user inputs, the next is identify server side technologies. So perform detailed server fingerprinting and analyze the HTTP headers and HTML source code to identify server side technologies. Examine the URLs for file extensions, directories, and other identification information. Examine the error page messages. Examine session tokens. JSession ID is for Java, ASP session ID is for IIS server, ASP.session ID is for ASP.NET, PHP session ID is for PHP. Commonly used server-side technologies include active server pages, ASP, ASP.NET, Cold Fusion, Java server pages that is JSP, PHP, Python, and Ruby on Rails. Use tools such as HTTP print and WhatWeb to identify server-side technologies. WhatWeb is also used in the iLabs. So HTTP print is a web server fingerprinting tool that relies on web server characteristics to accurately identify web servers. As you can see in the screenshot, this is how HTTP print looks. WhatWeb scans and identifies web technologies including content management system CMS, blogging platforms, analytics packet, JavaScript libraries, web servers, and embedded devices. WhatWeb has over 1800 plugins, each of which recognizes something different. WhatWeb also identifies version numbers, email addresses, account IDs, web framework modules, SQL errors, and more. So the screenshot is shown here when WhatWeb with the option -v is used on a movie scope. It displays the information like what technology is being used, ASP.NET, what is the HTTP server. Here it is Microsoft IAS, uh, who is the meta author, who is meta author is EC Council here, uh, modernizer, the script expowered by ASP.NET. So identify server side functionality. So after identifying server side technologies, this is about identifying server side functionality. Um, Server side technologies attackers try to identify the server side functionality to find potential vulnerabilities. They examine the page source and URLs and make educated guesses to determine the internal structure and functionalities of web applications. Following tools are used: GNU wget. GNU wget is employed for retrieving files using HTTP, HTTPS, and FTP, which are the most widely used internet protocols. If it is a non-interactive command inline tool, it is a non-interactive command inline tool. Hence, it can be called from scripts, uh, terminals without X Windows support. Examine URL in SSL certified page. URL starts with HTTPS instead of HTTP. If a page contains a .aspx, 1 second. So okay, so we to identify the server side functionality, we used JNU wget. Now there is another method uh, to identify the functionality is to examine the URL. So for example, if you see this URL, um, we can say because the URL is starting with the HTTPS, so we can say that a protocol used is HTTPS. Similarly, if the page contains an extension ASPX, the application is likely written using ASP.NET. If the query string has a parameter named show by, then you can assume that the application is using a database and will display the data by that value. So next is identify files and directories. So we saw identifying the entry points for user inputs, identifying server side technology, identify server side functionality. Now identify files and directories. So attackers use various techniques and tools to enumerate applications, hidden directories, and files of the web application hosted on web servers that are exposed on the internet. They use tools such as GoBuster and URL fuzzer and nmap nsc script http-enum to identify files and directories of the target web application. In iLab, nmap nsc script http-enum was used on goodshopping.com. So this is the screenshot of the output of the nmap. You can pause the video and look at the screenshot. GoBuster is a Go programming based directory scanner that allows attackers to perform fast paced enumeration of hidden files and directories of a target web application. It is a command oriented tool used to brute force URIs in the websites, DNS subdomains, names of virtual hosts on the target server, etc. So run the command GoBuster dir -u http certifiedhacker.com -w common.txt. As you can see, it is showing various directories and files. Use the -i flag to retrieve the -l flag to retrieve the length of the body along with the files and directories. So -u is for URL, w is to output to a file. So sorry, w will contain the word list. The output of nmap is also shown here. You can pause the video and watch the screenshot. So next, identify web application vulnerabilities. After identifying entry points for user input, identify server-side technologies, identify server-side functionality, identify files and directories. To analyze web applications, we will see identify web application vulnerabilities. Attackers can use tools such as Vega, WP Scan vulnerability database, Arachne, and Uniscan to identify vulnerabilities in the target web applications. Vega and WP Scan are also used in iLabs. Vega is a free and open source web security scanner and web security testing tool used to test the web applications. Vega helps you to find and validate SQL injection, cross-site scripting, inadvertently disclose sensitive information and other vulnerabilities. Vega also helps you to find vulnerabilities such as reflected cross-site scripting, stored cross-site scripting, blind SQL injection, remote file include, shell injection, and others. It also probes TLS SSL security settings and identifies opportunity for improving the security of your TLS servers. So this is the screenshot of the tool Vega. As you can see, the tool, we can go to scan and click on start new scan. So we can enter the URI for the target which has to be scanned, and then we can go to scan and start new scan on the Vega tool. So after starting, it will ask to choose which scanner modules to enable, and then the progress bar will be shown. So after scanning, it categorizes the vulnerabilities into high, medium, low, and information. So in this example, if you go to high, session cookie without secure flag is one of the vulnerability. Session cookie without HTTP only flag, clear text password over HTTP. These are the high alert vulnerability that it has found. In medium, it has found HTTP trace support detected and local file system paths found. Low, directory listing detected. Info X-frame options header not set. HTTP error detected. So we can go to scan alerts and then see all in detail about each of the vulnerabilities it has detected. Okay, then the next is map the attack surface. So once the attacker detects the entry points, server-side technologies, and functionalities, they can find their respective vulnerabilities and map the attack surface area of the target web application. Web application analysis thus helps attackers reduce their attack surface. Attackers consider the following factors in planning their attack. If you see this table, information, what are the information that needs to be considered and what are the attacks possible. Client side validation, the attacks possible are injection attack, authentication attack, database interaction. The possible attacks are SQL injection, data leakage, file upload and download, direct traversal, display of user supplied data, cross-site scripting, dynamic redirection, header injection, login, username enumeration, password brute force, session state, session hijacking, session fixation, injection attack, privilege escalation, access controls, clear text communication, data theft, session hijacking, error message, information leakage, email interaction, email injection, application code, buffer overflows, third party application, known vulnerabilities exploitation, web server software, known vulnerabilities exploitation. So email injection, we may have to search for this. What is the email injection? I was not aware of this. So after looking into the web application, analyze web applications, in the next video we'll see bypass client side controls.